Imagine you have a magical box that can create anything you want. You can ask it for an apple, and there's an apple. Ask for a pencil, and there's a pencil. Even ask for a unicorn, and there's a unicorn. Here's the strange part. The box doesn't decide what to create until you open it and look inside. Before you look, it could be creating anything. It's only when you open the box that it chooses and becomes just one thing: the apple, pencil, or unicorn. All these possibilities exist simultaneously inside the box. This is similar to how particles in quantum mechanics work. Before they're observed, they exist in a state where they could be many things at once. When observed, they collapse into one state. One interpretation of this is the Copenhagen interpretation. It suggests that observing a particle is what causes it to take on a definite state. This process is known as wave function collapse. The act of measurement interacts with the particle in such a way that it can no longer remain in superposition. Instead, it takes on a single, definite state. In our story, opening the box and looking inside is like observing the particle, making it become just one thing. The ancient Greeks thought the basic elements might be air, fire, or water. This was a revolutionary idea at the time, attempting to explain the diversity of nature with a limited set of fundamental substances. A century ago, physicists were sure it was the atom. Experiments like those conducted by Max Planck, Albert Einstein, Niels Bohr, and others revealed that atoms themselves were made of even smaller particles, and that these particles exhibited strange behaviors not explained by classical physics. Modern physics tells us that the building blocks of the universe are subatomic particles, such as electrons, quarks, and neutrinos. These particles are believed to be the fundamental constituents of matter, and all the matter we see around us is made up of various combinations of these particles. However, the story doesn't end there. Quantum theory reveals that the fundamental building blocks of the cosmos go beyond just particles, extending to the very fabric of space and time itself. In this framework, the universe is not merely composed of particles moving through space, but rather a dynamic interplay of fields and forces within the structure of space-time. These fields, described by quantum field theory, are the true essence of what constitutes reality, with particles emerging as excitations of these underlying fields. Today, we believe the deepest layer of reality consists of elementary particles governed by quantum theory. This invisible, tiny realm is where everything we see and experience originates. It's a world full of wonder and can often feel strange. Let's start with what we know. Visible matter is made of atoms, which have protons and neutrons at their centers. However, these protons and neutrons are not the smallest particles.